Good morning, guys, or good afternoon if this is fourth hour. I am unable to be in the building today. I have to be home, and so you are getting your video lesson instead of a regular lesson. So everything's going to be the same. A couple things, though. I'm going to ask the sub to please pause the video whenever I ask to have it paused, please, just to make sure that we get that taken care of. Kids will be filling in information at that point in time. Also, I am certainly going to be faster than a normal class, so feel free to pause it at any time. This video will be posted to Schoology, where you can find a link to this and then go ahead and watch it anytime as well. So if you don't get it today or you don't get it during this hour, you can go to your study hall, watch it, take notes, show your friends, family how great it is. All right, warm up. If you have not already completed the warm up, please do so. I would say go ahead and pause the video right now and go ahead and make sure everybody's got it finished. And if it's not finished, let's take a minute or two, really no more than 2 minutes to wrap up that warm up. Yeah, all right, good job, guys. You did the warm up. Okay, a couple of equations to solve here, and then we got some factoring that we're going to talk about, all right? Nothing scary, though, as far as the factoring is concerned. Remember a great skill to make this a lot easier in order for you to solve equations is to always take your subtraction and add the opposite, okay? That clearly tells me that this 9 is positive and that C is negative. So then my step is as follows. I subtract 9 from both sides, I undo that addition, and I get negative C is equal to negative 22. Now that C is not all by itself. I have to get rid of that negative C by dividing out the negative. Negative divided by negative is positive C, which is what I'm looking for. Negative 22 divided by negative 1 is positive 22. So hopefully we all got that. If not, hopefully you can see a mistake that you can correct. The next one, same thing. I'm going to go ahead and add the opposite so I can see that one being done. And see that it's adding, so I can see the sign of 2 is negative. What's happening to A, I'm dividing by 3, and then I'm adding negative 2, so I'm going to undo that first by adding 2 to both sides. 17 is then equal to A divided by 3, and now I have to undo this division by 3 by multiplying both sides by 3, stuff that we've talked about in the past. And so we end up with 51 is equal to A, or you can write it as A is equal to 51. All right? Okay, factors. We should know that this word means, factor generally means that we are taking 2 items and multiplying together. So what I'm asking you to do is list all the pairs of numbers that multiply to 24. So what are those pairs? 1 times 24 gives me 24. 2 times 12 gives me 24. Oh, boy, can't write that. Let's do this. 2 times 12 still doesn't give you the right. Hello. What else? We got 3 and 8. 3 times 8 gives me 24, and then last we got 4 times 6 gives me 24. In the end, we have this list of factors: 1, 2, 3, 4, 6, 8, 12, and 24. Typically, we want to list them in numerical order when we list factors. All right, factors of 25, much less. Start with the easy, 1 and 25. And then also 5 and 5 gives me 25. In this case, we are not going to write down the repetition of 5. And so we'll say 1, 5, and 25 are the factors of 5. Okay, moving on here. What are we talking about in this class today? We're talking about modeling expressions, not equations, expressions. I'm going to click through this pretty fast, and once it's all there, I want you guys to go back and fill it in, right? So what's an expression? It's a mathematical phrase that contains operations, numbers, and or variables. It has no equal sign, okay? This is something that we have talked about before, so nothing too surprising. Terms, the parts of the expression that are being added and subtracted. So let's talk about that for a second. If I write out 2x plus 3, my terms are 2x and 3, right? They are separated by addition and subtraction. We can actually write down a line through the middle and identify what our terms are. So along the lines of that, if I write out something like 3x minus 8 plus 4y, my terms, the same, are separated by addition and subtraction. So I have subtraction there, I have addition here. My terms then are 3x, 8, and 4y. However, if I were to just think of that 8 as 8 itself, I'm wrong because it's really adding the opposite when I subtract, so that 8 is really negative 8. All right, so get rid of that, move on. Coefficient. What's a coefficient? It is the numerical factor that can be multiplied with a variable term. So let's take a step back. If I look at this example right here, I have already identified my terms as 2x and 3. Well, my coefficients are the numerical factors of each term that have variables, variables only. That means that the coefficient, the only coefficient of this expression is 2. Okay? 3 has no variable part, so that means that 3 is not a coefficient. Coefficient is like number out front. Okay? Think of it that way. Numerical expressions, they contain only numbers and operations, and algebraic expressions contain at least one variable with their operations. So the difference here being that algebraic expressions contain variables. All right. If you need to pause the video to get that down, go ahead and do so. All right, hopefully you had time to go ahead and get those written in. If not, you can always go back and look at the video. All right, now we're going to do some practice of it. Identify the terms and coefficients of the expression. So I'm going to do the terms first, capital T. Remember, they're separated by addition and subtraction. So where is it? Here. And that creates my separation. So my terms are 5x, comma, 8y, comma, 2z. All right. Now my coefficients, when I list out my coefficients, I look at the terms that I've listed out. And here's what I look at. Does it have a variable? Yes, it does. What is the number up front? 5. That's my coefficient. Does it have a variable? Yep. What's the number up front? 8. Does it have a variable? Yes, it does. What's the number up front? 2. All right. When we get to a question, let's say I added like plus g, all right? So then g would be a term because it's separated by addition and subtraction. However, what's the coefficient on g? Well, whenever I write just a variable, there's always a 1 associated with it, right? So that means I would also have to list the 1 that is not explicitly written there. All right, so the coefficients of what I have now newly written are 5, 8, 2, but then also 1 if we have that there. Okay, moving on. Number 2, identify the terms and coefficients of the expression. What I would like you to do is to work on these two independently or with your groups, and then in a second after you pause the video, take a look at what they are, and then see how you did. All right, so hopefully you've had some time to work on this. And now let's go ahead and take a look at what they are. Terms in this one. Remember, a good idea is to always add the opposite so I can see clearly what everything is. And what that tells me is that, yep, 6 is a term, but then 5g is negative and so is 9. When I look at the coefficients, the only parts that have, 9k, sorry, I forgot that there. When I look at my coefficients, 6 does not have a variable. That's why it's not a coefficient. These both have variables, and the numbers out front are respectively -5 and -9. When we look at the last one here, this, bring it up to those in the back. Terms, separated. Remember, add the opposite, add the opposite. Boom, 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 boom. Those are my 4 terms. So they are 2g, or 2x, 7g, -12y, -6. But then remember, that does not have a variable part, which is why it does not appear in the coefficients. So it's just 2, 7, and -12. All right, moving on here. Let's look at how we can look at an expression that applies to a real-world scenario, and how we can break it down and ask for meaning. All right? Tickets to an amusement park are $60 for adults and $30 for children. If A is the number of adults and C is the number of children, then the cost for A adults and children and C children is 60A plus 30C. What does that mean? Well, let's say 8 adults show up, then I would substitute 8 in for A. And let's say 4 children show up. These numbers are really small for amusement parks, but whatever. Then I would substitute 4 in for C, and then I would compute 60 times 8, 30 times 4, and then I would get the total cost of what they brought in that day, or that minute, or whatever. Okay? Okay, just looking purely at the expression, though, what are the terms? I think that's fairly simple. We've talked about it a lot. 60A, comma, 30C. All right? What are the factors of 60A? Now, when I ask you the factors of 60A, I'm not asking you what are the factors of 60, right? I want to just look at the basic multiplication, and the basic multiplication is 60 times A, and so the factors there are really just 60 and A. That's what we're looking for. For the same reason, what are the factors of 30C? That is 30 and C. Then if we look at the next question, what are the coefficients of the expression? Well, 60A, 30C, they both have variable parts, so then 60 and 30 are the coefficients of that expression. Now we interpret the meaning of the two terms in the expression. All right, we already kind of talked about this. So what does 60A represent? Well, that represents the cost for adults attending. And then the 30C represents cost for kids attending, children attending. All right, so that's breaking down that expression. I think we're actually going to skip this one. It's an okay example. However, I would much rather go through this reflect question here. So let's go ahead and put a big X through this guy. If you want to look at the notes online for it, go ahead. But I think for the purpose of this video in class, I think we can go ahead and skip that for now. I want to focus on this question here, number 6. It says, Sally identified the terms of the expression 9A plus 4B minus 18 as follows. 9A, 4B, and 18. Explain her error. Okay? I want to give you guys maybe 30 seconds to think about that error because it's very common, and then I'll tell you what the error is in a second. All right, hopefully you've had some time to talk about that error. The big thing here is that this person probably, oops, I'm not using the pen here, probably did not go through and add the opposite, right? If we do that, then I can see clearly that that 18 is negative, and that's what the error is. Okay, so the error is that it should be negative 18. Number 7, what is the coefficient of B in the expression B plus 10? Well, we've actually already talked about that, didn't we? When I just have a simple variable by itself, that means that there's really a 1 in front of it, so the coefficient for B is just 1. All right, moving on here. Again, we're going to look at some expressions. I want you to go through 8, 9, and 10, and I want you to read them. I want you to answer the question, what does the expression given mean? All of those present different situations, and they all mean something different, all right? So go ahead and take maybe 3 minutes to read through these and give the meaning of each expression. All right, hopefully you've had some time to discuss this. Let's read it real quick. Curtis is buying supplies for school. He buys P packages of crayons at $1.49 per package and Q packages of markers at $3.49 per package. What does the expression 149 times P plus 349 times Q represent? Well, to me, I'm taking P packages of crayons and multiplying it by $1.49, and then I'm adding that the same way for the packages of markers. And what does it really represent? This represents the total cost of P packages. Now, if I know how many packages of crayons and markers I bought, I can use this expression to model the cost. Next one. George is buying watermelons and pineapples to make fruit salad. He buys W watermelons at $4.49 each and P pineapples at $5 each. What does the expression 449W plus 5P represent? Again, what are we doing? We're taking how much a watermelon costs and multiplying it by how many watermelons we buy, how much a pineapple costs, multiplying by how many pineapples we buy. This represents the total cost of W watermelons and P pineapples. All right. Lastly, Sandy buys 5 fewer packages of pencils than P packages of pens. All right, let's read that one more time. Sandy buys 5 fewer packages of pencils than P packages of pens. Pencils cost $2.25 per package and pens cost $3 per package. What does the expression, I'm not going to read it yet, represent? Well, what are we doing? Well, I'm buying 5 fewer packages of pencils than pens, and it's telling me I'm buying P pens, right? And in order to figure out the cost of pens, it says that I'm buying, it's $3 per package, right? So in order to figure out the cost of the package of pens, I have to take that $3 and multiply it by P pens. But I'm also buying pencils, right? Pencils cost $2.25, and this is how we're multiplying at P minus 5. Where does that come from? This part here. 5 fewer packages of pencils than packages of pens. And we bought P packages of pens. So we have to take that P and subtract 5 in order to figure out how many packages of pencils we bought. So that's how we get our cost. So this again represents the cost of just pencils and pens. However, I didn't want to go through the explanation of what that expression means. All right? Good deal. So next exercise is a little bit abstract, but I think it's good. It says, suppose X and Y give the population of 2 different cities where X is greater than Y. Compare the expressions and tell which of the given pair is greater. So then we're given a pair each, right? We're given X plus Y and 2X. We're given X divided by Y and Y divided by X. Okay, so think about this. We're giving a value of X that has to be greater than the value of Y. And we're using them in these situations and seeing which one is greater. I want to give you guys a minute to try and figure out which one might be greater, any way you want to choose. And then after that minute's up, I want you guys to go ahead and see what I have up here and compare and see what you did. All right, hopefully you've had time to go through that. Here's what I did. I'm going to say that X is equal to 2 and Y is equal to 1. I'm just going to give values that match this, right? Because X has to be greater than Y. If that's the case, if I do that, then I have 2 plus 1, and that's equal to 3. The other one is 2 times 2, and that's equal to 4. So according to this, 2x is greater than x plus y. And that should make sense because what does 2x mean? It means I'm taking something and repeatedly adding it 2 times. And if I take it and add it to something that's smaller than itself, it's obviously going to be smaller. That result will be smaller than adding to itself. Okay? So always, this situation will be true. If we do the same thing here, if x is equal to 2 and y is equal to 1, then if we follow what we have here and substitute, I have 2 over 1, which is obviously 2. And then I have 1 over 2, which is, well, 1/2 or 0.5. So which one is greater? Obviously, x over y is greater than y over x. And you can do that with any example. Let's say x is equal to 7 and y is equal to 2. If I have 7 over 2, that's 3.5. But if I have 2 over 7, that's obviously way less than 3.5. And so this scenario will always be greater. All right? I'm going to skip this portion here because it's more of the same type of reasoning, but it's not super necessary for what we need here. All right, so let's go right to this table. Modeling expressions. So a couple things about this. Modeling expression in context, what we have here are really the operations, the words that mean those operations, and examples of those being used, right? So what are some words for addition? You can read them here. We got sum, we got added to, all together, total, all that stuff. Subtraction, we got less than, we got take away, taken from, reduced by, all that stuff. Multiplication, what I want you to focus on is that percent of, or really just the word of. Of means multiply. Notice it's the product of as well. Division, not too many, divided by, division of, quotient of, all that stuff. All right. You can also look at this table to reference some examples of those being used. So, for instance, 60% of a number means 0.6n. Okay? 60% of a number means 0.6n because, what does that mean? 60% of the decimal is 0.6. Of means multiply, and number just means variable. All right, what we're going to be doing is translating those words into expressions. And so here's our first example. The price of an item. Boom. That's the first phrase. Plus, that's an operation. Then 6% sales tax. And what you have to interpret that is, it is 6% of the original price. So here's what we got. Price of an item. We'll call that P. Plus, and then 6% of the original price. Well, that's plus, so we have to convert 6% to a decimal, 0.06, and what's the original price? It's just P. So we have P plus 0.06P. And I can actually simplify that expression by saying, well, 1 plus 0.06P is 1.06P. This is something you can actually use whenever you go to buy something that's not food, because food's not taxed. But you can take the price of anything that you're going to buy, go ahead and multiply it by 1.06, and you will get the price after tax. Okay? I believe the sales tax is either 5 or 6%. Now that I think about it, maybe it's 5%, so maybe 1.05 in Wisconsin, but don't quote me on that. All right, the price of a car plus 8.5% sales tax. Well, this is basically the same model as before. It's the price of a car. P plus means addition, and 8.5% sales tax. Remember, that's of original price, right? So that's plus 0.085 converted to a decimal, P. Remember that P really has a 1, and I can simplify it to 1.085P. So this would be the same exact scenario as before if the state that we lived in had an 8.5% sales tax. Whatever you're buying had an 8.5% sales tax. Okay, writing those in an expression to model the given context. Give your answer in simplest form. And we're almost done here. All right. There is water in a tank that already has 300 gallons of water in it. It is being filled at 35 gallons per minute for m minutes. We are writing an expression to model it in context. All right, well, I want to write an expression that will help me figure out how much water will be in after m minutes. Okay, so how much water is already there? 300 gallons. If I'm filling it, am I adding to it or subtracting? Obviously, I'm adding to that 300 gallons. And now I just have to figure out how much am I adding and how often. Well, I'm adding 35 gallons, but I have to add an additional 35 gallons every minute. So I multiply by how many minutes. All right, next one. The original price, P, of an item with a discount of 15%. So now this is opposite of tax, right? We're getting a discount, we're going to pay less. So I'm going to take the original price of that item, and now instead of adding like I did before, I'm subtracting a discount. All right? And now what am I subtracting? 15% of the original price. 15%, 0.15 is a decimal. Of means multiply times P. And again, to simplify that, I got 1P. I subtract 0.15P, and I end up with 0.85P. All right? So you can use that anytime you go to the store. Let's say you get a 20% discount off of something, right? If it's 20% off, that's really what's remaining, right? What's remaining after 20% is taken away. If I start with 100%, I take 20% away, I'm left with 80% of the price. 0.80 is what we would use. All right, last couple questions here. I'm just going to generalize these. When given an algebraic expression involving subtraction, why is it best to write the expression as addition before identifying the terms? All right, so we can keep track of negative signs. That's the biggest mistake that I see. So if we just change all of our subtraction to adding the opposite, boom, boom, then we will be able to keep track of our signs much more easier. All right, more easily. How do you simplify algebraic expressions? We do as many operations as possible, and we combine like terms. That's all we can do. And remember, when we're doing this, if we're simplifying expressions, we're using PEMDAS, right? PEMDAS. And then how do you write an algebraic expression to model a quantity? That's a very, very open-ended question. And that's basically what we are doing here, right? 17 and 18. We are reading a situation. We are interpreting the numbers that come in that situation. We are seeing how the math is applied. And we're writing an expression. So for instance, in this one, if I now ask somebody like, all right, well, how many gallons will be in the pool in 65 minutes? Oh, 65 times 35 plus 300, bam, you got your answer. All right? There's no surefire way. It's all about interpreting the language to a math expression, which we will get better at as we move on. Okay. Now your independent practice. You will be given a strip of paper that will have your email address and a temporary password. You are going to go to my.hrw.com and you are going to log in with this email and password strip. And once you log in, you should be able to find your online textbook. Okay? In fact, I can model that for you right now. That's a pretty good idea. Let me bring this up. So here's what it looks like when I log in. My username and password are already there. I click login. Mine's going to look slightly different than yours. Right now, if I click this drop-down menu over resources, I have to go to Algebra 1. If I click on Algebra 1, then I have to look for I have the teacher edition here. You might have to go left or right to find student edition, which is right here, right? And so I click on student edition. Then, for tonight's independent practice, you're going to go to quantities and modeling. We're still in Unit 1. But now we're in Module 2, and then we are in Lesson 2.1. So if you click on Lesson 2.1, it'll bring up the student edition, and you now have the independent practice. A couple things about this. The independent practice homework that we are assigning you does not start until this page. All right, so it starts on page 41. Notice there are numbers and examples before that. That's part of the in-book lesson. All right, so going back to this, your independent practice is listed on your handout for you. And remember to use Schoology to check your answers as you go. I hope you guys have a great day. Peace.